we're going to look at how to graph any tangent function given that we now know what the parent function looks like. So in the previous video, we looked at how to graph y equals tangent of x. From that, we should have memorized by now the three values that are the key points. So it occurs at negative power 4. I'm highlighting the above in purple, negative power 4, at 0, 0, and at power 4. And that occurs in cycles, so we can repeat the cycle if they want us to graph 2 cycles. So the important thing to keep in mind is that the period is at pi. So we want to make sure that when we go to graph the next function, we are keeping that in mind and that the period might be adjusted. So if you take a look at the equation that we have here, 4x, 2 equals, or y equals 2 tangent of 4x, the period is adjusted because there is a constant value in front of x, so similar to sine and cosine. I'm going to erase the table of values here. We don't need that. We're going to use what we know from the previous example to come up with what this graph is going to look like. So let's first figure out the period. To figure out the period for any trig function, you take what the typical period is. So for sine and cosine, it was 2 pi. For tangent, it's pi. And you divide it by the b value, which is the value that you have in front of x, so 4. So this tells me that instead of the period being pi, we have pi over 4. Now, so in order for us to get what pi over 4 would look like, what I do is I find my x-axis and I look at it divided in, similar to sine and cosine, into 4 regions. And then we have to figure out, well, what do we have to label these angle measures such that when I look at my graph, I see from here to here, the total value in terms of units is pi over 4. So if I want half of pi over 4 on one side and the other half on the other side, that means I'm timesing pi over 4 by a half. So pi over 4 times a half is pi over 8. So 1/8 plus 1/8 is 2/8, which is pi over 4. So that's going to give me the values at which I have my vertical asymptotes. So pi over 8 and negative pi over 8. So we'll go ahead and draw my vertical asymptotes at those values. So negative pi over 8, pi over 8. And then from there, we can go ahead and draw the next vertical asymptote over 4 units to the right because we want to complete 2 cycles. Of course, you can also go to 4 units to the left of negative pi over 8 as well. That wouldn't be incorrect. And then from there, you have your coordinate points. And we just need to figure out what the values would be at the smaller angles and what we're jumping by. So if this value right here is pi over 8, what would the value before that be? Well, it looks like it's half of pi over 8. So that means that each one of these units is pi over 16. So 1 pi over 16, 2 pi over 16 makes sense because then that gets me pi over 8. Then this would be 3 pi over 16. 4 pi over 16 is pi over 4. 5 pi over 16, and we end at 6 pi over 16, or 3 pi over 8. Okay, and then we can do the same thing in the opposite direction, negative pi over 16. And from there, we're going to picture, and I'm going to highlight these points first and then come back in and delete them. So once you have that set, then you just superimpose, okay, well, we know that there should be a point here, there should be a point here, and there should be a point here, and it looks like the x cubed function. However, if there's any shifting to the tangent function, whether it's left and right or up and down, we're going to take those points and move it left and right, up and down, based off of phase shifts and vertical translations. However, there is none on this function. There is a 2 out front. So if we remember what this 2 value does in first semester, it was a stretch. So if it's a value greater than 1, it's going to stretch. If it's a value smaller than 1, it's going to compress. So let's take a look at your first point, 0, 0. If I take 0 and I times it by 2, the y value of 0, and I times it by 2, I get 0. So you can't stretch that value. However, this point right here, if you were to take pi over 16, 1 and times it by 2, it does cause a stretch of that 1 to be 2. And then same on the negative side. At negative pi over 16, this point right here that was negative 1 gets stretched to negative 2. So similar to when we were doing parabolas and x cubed functions. So now we do the same thing on the next phase, and at 3 pi over 16 it gets stretched to negative 2. Pi over 4, it's the origin, and then at 5 pi over 16 we have that coordinate point right there. So when we sketch our function, we're going to see that it got stretched out because of that too. Now, if they were to ask us for what the domain and the range is, let's start with the easy one. The range is, well, my graphs point up and down forever, so negative infinity to infinity. My domain is, well, we want to say all real numbers except, so that's x and then bar. So we want to somehow define where it can't be equal. So we're saying x is, it could be anything except 4, and we see that it's pi over 8. The first vertical asymptote is 1 pi over 8, the next one is 3 pi over 8, the next one after that is 5 pi over 8. So we would say k times pi over 8, where the k value is an odd integer. So let's go ahead and define that k to be any odd integer. So k is any odd integer. Okay, and then for vertical asymptotes, we want to define where what those yellow lines are. So x equals, we see that it's pi over 8. And since the period is pi over 4, it's occurring every pi over 4. So we say plus pi over 4k, where k is any integer. And if that totally doesn't make any sense to you, I would encourage you guys to plug in an integer like 1 and see if it matches 3 pi over 8. Plug in 2 and see if it matches the next one, 5 pi over 8, and so on and so forth.